Okay, guys, we've been talking about polar coordinates and rectangular coordinates. What is this nonsense?
I have a tardy slip.
Did you forget?
Yep.
You are tardy?
Yes, sir.
Have you ever been tardy anywhere in your life?
Nope.
What happened?
I thought I had enough time to feed the rabbits this morning, and I did not.
Do you realize how many times I've heard the I had to feed the rabbits excuse? It's like, really. Okay, let's take a second and let you catch your breath. Okay,
Yes, sir.
get settled in. Okay, get some paper.
I called it. I was like, I bet Catherine is going to be late. Oh my god. Well, when you text me at 8, asking, hey, where are you? I'm like, crud. Didn't realize how late it was.
Was it excused or unexcused?
I don't know. I have no idea.
Okay. Ouch. Ouch. Okay, so in polar and rectangular, does it really make sense going back from polar to rectangular and rectangular to polar? Does it make sense to you? It's like a triangle, right? It's just you're doing SOHCAHTOA. That's all you got to look at it, right? So that makes a lot of sense. But what we're going to talk about today is you can have a polar equation and a rectangular equation, and how would you go between the two? So like if I have the equation y is equal to x squared, somebody stands up and yells what?
It's a quadratic.
It's a quadratic, right? Okay, you're right, it's quadratic. And what is this in, like what type? Would it be like polar or rectangular? Yeah, it's rectangular. Okay, but let's say I wanted to plot this in polar. So I want to convert a rectangular equation to a polar equation. Would anybody throw out something that they might suggest? Just talk out loud, something that we might try. What do you think, Ben? Would I know anything maybe about y?
Y equals r sine theta,
Yeah, r sine theta. We know that.
and x equals r cosine theta.
Somebody throw out something we could try.
Could you get the sine squared and the cosine
Now,
squared?
how about just something real simple, like where I have a y, I put in what?
Oh, r sine theta.
And then do the same for x.
But that would be doing it the easy way. Okay, and so now I'm going to put parentheses, and x is r cosine theta, and then whole thing what?
Squared.
Why was it so important to put the parentheses in?
So the square is over the whole thing.
Yeah, you got to remember to square the r. So r sine theta is equal to r squared cosine theta. All right. Now this is
Isn't
some.
it cosine squared theta?
Oh man, yeah, thank you. I was just making such a big deal of the importance of squaring everything as I didn't square everything. Okay. Now what you guys have got to see is don't take the square root of both sides, right? Like let's say you really kind of, it would be good to solve for r. So what's the easiest way to solve for r?
Divide both sides of the equation by r.
Yeah, okay, because that way you eliminate the r. So I would have sine theta is equal to r cosine squared theta. Catherine, what would you do now?
I would divide both sides of the equation by cosine squared theta.
Yeah. Boom. See how easy that is? Now instead of picking an x and plotting y, you could pick a theta and plot r. Does that make sense?
Mm-hmm.
Okay. Now, let's go the other way. What if I said r is equal to 2? This is in what?
Polar.
Okay. And I want to go to what?
Rectangular.
So I need to know x and I kind of need to know y, something like that, right?
Mm-hmm.
Somebody suggest something that I could do.
Well, r equals the square root of x squared plus y squared.
That is true.
Huh. So what could I say? The square root of x squared plus y squared equals
2.
2. I could square both sides and I could say x squared plus y squared equal 4. Okay. And somebody should scream that this is a what?
Circle.
Circle,
Oh, that
right?
is. Mhm.
It's a circle. X squared plus y squared. A circle of radius
2.
2.
2.
Because it's x squared plus y squared is r squared. Right? Well, think about this. So this would be 1, 2, 1, 2, 1, 2, 1, 2. It would be like that. Okay? Well, if you were going to plot in polar r equal 2, what would that look like?
It would be
You have a line that's 2 units long that you just rotate all the way around.
Yeah, because it doesn't say r equal 2 theta. It doesn't depend on theta. For any theta, r is always
2.
2. So you see, it just swings all the way around and the r equal 2. Does this kind of make sense, I hope?
Yes, sir.
Okay. Kind of. Let me work a couple more of these times. I have theta equal pi over 3. What units am I in?
Oh,
What?
Radians.
Polar. Okay. Okay. Now, if you think about, like, let's just think about plotting this before we do the conversion. Just talk out loud how you would plot this. What does it mean?
that
For any r, theta equals pi over 3.
Okay, and so you are exactly right. Then what would that look like as a graph? Is it a circle? Is it a sign?
A line.
It's a line, right? It's a line like that. Okay, so that's just kind of good to think about. Now, how would I change this to rectangular?
well, you know that x equals r times cosine theta.
Okay, okay. Let's think about that. What was what was that?
Theta equals tan inverse of y
yeah,
over x.
yes.
Okay, theta equal tan inverse of what?
Y over x.
Y over x. Okay, so
Wait, tan inverse? That was just tan.
No, it's tan inverse.
okay. So then what we could say is now, you were right, we could take the tan of both sides. Tan theta is equal to y over x, right? Those are both true. Those are kind of the same thing, right? So what is theta?
Hold on, why would it be just
Wait,
tan?
where did you?
Because I took the tan theta and tan of tan inverse. Tan undoes tan inverse.
Okay.
Does this make sense?
Yes.
Okay. All right. What can I do now? Because I'm not in rectangular because I've got theta there. I got a y and an x is good.
That is good. Oh, you can actually do the tangent.
Does this help?
3. Yes.
Oh, okay. So I have tan of pi over 3, use what you know, is equal to y over x. Now, as we're working, since we kind of plotted it to begin with, we know we're trying to kind of end up with the equation of a what?
Of a line.
What's good? I have a what and a what.
Y and x.
And I want it to end up as what equals what?
Y equals mx plus b.
Yeah. Okay. So now, I should probably do what with tangent of pi over 3?
Well, you could split it into sine of pi over 3 over cosine of pi
Uh-huh.
over 3.
And you could look at your unit circle and you would see that tan of pi over 3 is square root of 3. Okay. And I get that from what?
The unit circle.
The unit circle, not the what.
Exactly.
We get it from the unit circle, right? Because that's the answer is equal to y over x. Now, why am I happy? I've got a Why?
X and a y.
x and a y, but I need to make it like a line. So what would you do to both sides?
Multiply both sides of the equation by x.
You are really, it's like,
It was the adrenaline rush from this morning. Woke me right up.
no, I mean, you're really, it's like things are making sense, right? Very good. Y is equal to the square root of 3x. Okay. Now, what is the slope of the line?
Square root
Square
of
root
three.
of three.
Yeah. Y equal mx plus b, y-intercept is 0.
Okay, Miss Sparkle, I have a question. You used tan inverse, but in the note, you just used tan,
No,
like right here.
it says theta. I said tan theta is y over x, right?
Oh,
But what Catherine did was she kind of went back to the thing that we did before, which is theta equal tan inverse of y over x, which is right.
okay, then, never mind, I'm not confused.
Okay, I want to make sure though.
Yeah,
Remember
I
when
get
we
it.
were doing converting a point from polar to rectangular, this is the equation we had. So she started there. And then, okay, you can start there, and then we just put this step in to get to here. All right. So what if I say r equal secant theta? Which units am I in?
Polar.
I want to go to rectangular. What's the first thing that you would do? Like when you see this, just your intuition should tell you the first thing I would do is what?
Change it.
R and
Change
theta.
to 1 over cosine.
You're thinking r and theta. That's right. But even before that, I always get rid of the what?
Seek.
Yeah. Life is hard enough just knowing how to do sines and cosines. I don't want to know how to do secants. The way I do secants is I know how to do sines and cosines rock solid, and then anything I do, I turn into. Okay. So r is equal to 1 over cosine theta. I hope I did it right, because after that big speech, if I didn't convert it right, I would look kind of silly. Okay. Now, just even, but what would you do now? Just what would make sense to do? Like, do we like denominators?
No,
No.
so you would multiply both sides of the equation by cosine theta.
It's sort of like, I like to clean things up before I even do the problem. I hate denominators. I like to get rid of secants. I like to get rid of denominators. All right, now we got to think about, Catherine, the what and the what.
The r and the theta.
Okay, so what is something that you could do here?
You could
R
have
equals the square root of x squared plus y squared.
This is true, but there's a simpler thing you could do.
yes, because
What is r cosine theta?
Oh, yeah,
It's
x. Well, that was easy.
boom. Okay. All right.
Yeah,
Yes.
I liked that one.
Same. This much made that very hard.
All right. You guys have the homework, okay?
Okay, thank you.
Please promise me you'll never use the "I was feeding my rabbits" excuse.